All right, so we're looking at second day of factoring. And so yesterday we started quadratics. Let's finish up with some quadratics tips. Okay. First, as we put in yesterday's notes, you want to look for that GCF. Okay. Second, if it follows one of the special patterns, you might save a little time on sort of working backwards and being able to factor that way. So if it's in the a squared plus 2ab plus b squared, you can easily factor it to a plus b squared. Or if it's a squared minus 2ab plus b squared, it's going to be the a minus b quantity squared. And then the one that I always think saves the most amount of time is the a squared minus b squared. Factors to the a plus b times the a minus b. So those are the three special patterns that can make it faster for you. And how do you know when to use them? You know when to use them when you have perfect squares. So always look for perfect squares. And you can do perfect squares on the calculator, but you guys are at a point in your math knowledge where you should be able to recognize them, right? Like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So you should be able to go all the way up to 100, like not even having to think about it, right? Okay. You also need to be able to look at your variable parts and see if they're perfect squares, like x squared or y squared. Even a to the 4th, you should recognize that that's a perfect square, and b to the 8th, okay? Or s to the 2nd and t to the 6th. These are all perfect squares, okay? All right. After you've looked for special patterns, the next thing you should look for is easy factoring. Okay. Once you've pulled out a GCF, that's basically meaning it's going to have a 1 as the leading coefficient. It's going to look like there's no number there, but there's a 1 there, right? That makes them a little bit easier. I call these easier because you should just use the X method. Okay, and some of you don't even necessarily need to draw the X. You just do what I learned when I was in high school. You use guess and check. Like your brain just automatically goes there. Okay? If it's not easily factorable, then you want to try the 4th thing. And you usually do this when you have a leading coefficient other than 1. Okay, so if the leading coefficient is 1, use easy factoring. If it's not, or it's 4 terms, you're either going to use grouping, if it's 4 terms, or you're going to use slip and slide. I call it slip and slide. You may have learned it as master product, just depending on who your teacher was. Or okay, they're basically the same thing. Okay, so let's look at a few problems. Example number 1. We have 28s squared t minus 28st squared plus 7t cubed. Bless you. Okay, so follow through the list. First, we need to look for GCF. Is there a GCF? 7 is the numeric part. What about the s? Well, there's an s squared here, there's an s here, but there's no s here. Okay, but we do have a t in all of them, and t to the 1st power is the greatest one, right? That'll go into all three terms, okay? So we can factor out a 7t. That leaves us with what for the first term? 4s squared. Right away, what do you notice about 4s squared? It's a perfect square. So it's likely that it's going to follow a special pattern, right? Okay. What's left in the second term? Minus 4st. Okay. And what's left in the third term? T squared. Is t squared a perfect square? Yes. Okay. So if this term is a perfect square and this term is a perfect square, it's likely, very likely, that it's going to be a special pattern, which is number 2. Okay. What's the square root of 4s squared? 2s. And what's the square root of t squared? T. Okay. Now, to determine what sign it's going to be, you look at this term right here, right? So this should be 2s minus t squared. And then make sure you bring down that 7t. All right? Any questions on example number 1? All right, let's do one more and then we'll jump into cubes. I'm going to move this up. You'll see it in just a sec. Example number 2. All right, first we want to look for GCF, right? Greatest common factor. So look at all 4 of your terms, right? You've got 1, 2, 3, 4 terms. So what is the numeric GCF? 5. And then we've got 2 variables. So let's check the x's first. X to the first is y in all of them. No. Okay, so the GCF is 5x. So we're going to write what's left inside those parentheses. So from the first term, what's left? 3xy. Okay. How about the second term? 4. How about negative 4? But yes. Third term, what's left? Minus 6x. And the fourth term? 2y. All right, everybody with me so far? Okay, so we pulled out the GCF. Is this one going to be a special pattern? No, we don't have perfect squares, right? Okay. How about, is it easy factoring? Does it have a leading coefficient of 1? No. Okay, so jump to number 4. Does it have a different leading coefficient, or is it 4 terms? Yeah. Yes, it's 4 terms, right? So we're going to factor by grouping. We're going to group those first 2 terms together, and we're going to group those second 2 terms together. Okay? I know eventually I'm going to need to bring down that 5x, right? Is there a GCF with the first 2 terms? There is not. Oh, I know what I need to do. There is not one. So we actually need to switch our grouping. We should switch the 3xy to go with which one? 6x. The minus 6x. So it should be 3xy minus the 6x. Let's group those 2 together instead. That leaves us with our second group of negative 4 plus 2y. All right. Now do we have a GCF? Yes, which is 3x. So pull out a 3x. And left is a y minus 2. What's the GCF in the second grouping? 2. how about negative 2? Yeah. Oh, let's switch the order, right? Because we want it to match this as closely as possible. So if we change it to 2y minus 4, see what I did there? What's the GCF? 2, so pull out a 2, and that leaves us with y minus 2. Okay, so you can fiddle around with the order a little bit on that grouping to help yourself out, okay? So here's the one that's the same, the y minus 2. And then what's left over is the 3x plus 2. And then remember, we factored out that 5x as our GCF to start with. Okay?